Hello, welcome to our last meeting. Thank you for being here. All right, so let's go ahead. I just posted a review online. I posted it not so long ago. We will go over the remainder of review. So I was thinking of what we should do in terms of the open response and multiple choice. So there'll be 10 multiple choice and there'll be 5 open response. So I already gave you the first 7 types of questions you'll see in your multiple choice. Let's go ahead and take a look at the remainder of it. All right. Let's go ahead and look at your review. Unless there's any homework questions. Are there any homework questions? Any homework questions? Okay. So let's go ahead and take a look at the review. Let's look at the multiple choice one first. All right, so I was thinking of what I want to do for our review. And I thought 10 multiple choice would be plenty if I plan to do another part, which is those five open response ones. All right, so let's take a look at these. So you have 3 problems left from your open response. And one of them, like this number 1, is going to be a system of linear equation with a system of linear equation with 2 variables. And you can solve it any method you'd like. I mean, I'm not going to check your work for those multiple choice questions. It's elimination, but if you're a substitution person, you can do substitution. All right, let's take a look at this question. So we want to solve using elimination. And I see here that I have an x that has no variable. Here I have a negative x. So we see, if we multiply that first one by a positive 7, that would make it so I have a 7, and that would add to make 0, right? 7x minus 7x is 0. So let's go ahead and do that. So that I have 7x, negative 6 times 7 gives me negative 42y, and 24 times 7, have a calculator, we get 168. And then we rewrite our second one, which is negative 7x minus 7y equals negative 21. All right, so then we see these add to make 0, they're gone. And we're left with negative 42y minus 7y, we get negative 49y is equal to 168 minus 21, 147. All right, then we divide by 49, negative 49, we get 3. So we get y is equal to negative 3. So we can kind of cheat at this point, right? Which one has y as negative 3? And only one of them does, right? So we know there should be an answer, but let's go ahead and finish it off. So now with y equals negative 3, let's plug it back into one of our original equations. Let's pick that first one. So I have x minus 6y is equal to 24. And now we have that y is equal to negative 3. Let's plug that in. So I have x minus 6 times negative 3 equals 24. Negative 6 times negative 3 gives me positive 18. Let's rewrite our equation. We subtract 18, subtract 18. We have x is equal to 6. So my answer is a coordinate point 6 comma -3, which is what we boxed. We knew that was going to be our answer already. Any questions on 1?
No.
No? Alrighty, let's go ahead and take a look at 2. Write the expression as a logarithm of a single expression. Assume the variable represent positive numbers. Okay, so we have multiple logs. We see we have a log here, a log here, and a log here, and they're all the same base, and our goal is to write it as 1 log. Okay, let's go ahead and do that. So we see that in parentheses, we have these that are subtracting, right? So when we're subtracting, we can write it as division using only 1 log. So we have log of base A, and we write our first one over our second. And we still have that left over, and I have plus 2 log of A, base A of U. All right, I can go ahead and take that number that's being multiplied in the front and write it as an exponent. So we now have, around the bottom, log base A of T over S plus log base A of U squared. All right, one last piece. I want to write it as 1 log, and I have 2 logs. You see they're being added. So because they're being added, I can multiply them. I can multiply and write them as 1 log. So that I now have log base A of T over S times U squared. And we can write that U as U over 1. So we have log base A of T times U squared over S. And we see that A is our answer. All right, last one. Let's go ahead and look at this compound interest problem. Find out how long it takes a 3,300 investment to double if it's invested at 9% compounded quarterly. Round to the nearest 10th of a year. Use the formula A equals P times 1 plus R over N times NT. And I like this one because you have your formula, right? You're not thinking, oh, which one is this again? So you just have to go ahead and plug in those values. So that we have A is equal to, and now I have to find those values. P, R, N, and T. All right, P is your starting amount, your principal. We're starting with 3,300 or 3,300. And then R, our rate is 9%. Remember to change your decimal over. So our decimal points here, we have to move it to the left twice. 1, 2, we're here. So that we have 0.09. Our N is how many times it's compounded. We see the word quarterly. So because we see quarterly, that means 4 times a year. So 4. And T is time in years. How many years did it tell us?
10th.
Pardon?
10th of a year.
Round to nearest 10th of the year. Ooh.
That's going to be a variable, I think.
Find out how long it takes. Find how long it takes a 3,300 investment to double. Oh, we're given the double. So we've done some like these. So we know A. Double would be 6,600. And T is unknown. We did one like this before. I won't make it like this. It'll be so that you can solve for A, but we can still do this one. All right, so A is 6,600. P is 3,300. And I have 1 plus R, which is 0.09 over N, and N is 4 times N times T. So N is 4, and then we have our T are unknown. You can write T, you don't have to write X. All right, let's go ahead and solve this. So let's go ahead and simplify the inside. So you're gonna need a calculator for that. I have my calculator out. You can use your phone if you're not using it for Zoom. So 0.09 divided by 4 equals plus 1 equals. And so we get 300, 3,000 times 1.0225 times 4 raised to the 4t power equals 6,600. All right. We want that variable with the exponent isolated so I can take the log of both sides and then bring it down. So I need to divide both sides by 3,300. All right, and that gives us 2. 2 is equal to 1.0225 raised to the 4t. All right, our problem here is our exponent is in our variables in the exponent's place. So let's go ahead and take the log of both sides so I can bring it down. All right, so now this allows us to bring our 4t to the front. So we now have log of 2 is equal to 4t. 4t log of 1.0225. All right, almost done. All of this is being multiplied, right? And our goal is to get 2 by itself. So last piece, let's divide by those values. 4 log of 1.0225. 4 log of 1.0225. And that's calculator work. Let's go ahead and get our calculator. So I have log of 2 divided by 4 times log of 1.0225. All right, and my answer is 7.787957.4, and it continues a bit more. Now, in our question, it wants us to round to the nearest tenth. So 2 decimal places. 1, 2. I look at the 1 next to see if I round up, and I do. So if I round, this is 7.79. And the one that's closest to it is D. That's not good rounding. We did the rounding right. They didn't have the rounding right. All right, so with the exception of problem 3 will be a straightforward compound interest question. You have seen your 10 multiple choice questions for your review. You will have a total of 10. We did the first 7 on Monday, and I gave you the last 3, but we're not done yet. We also have an open response part to our exam. All right, let me show you your open response. All right, you begin by having 3 questions, so you'll have to answer. And the other 2 questions, there's 5 questions. The other 2 questions will be open response questions for you to answer. So let's take a look at those last 2. The last 2 questions are, What was the concept you enjoyed the most? Write a brief reflection on how and why you enjoyed it so. And I want 2-sentence minimum. So you could say something like, it came easy to me, it's something I remember from the past, or you just like working with it, you felt like you really understood math. I don't know how it made you feel, but I mean, be sincere. Only I'm reading it, so you don't have to worry about being nerdy or anything like that. Please nerd out. Let me know why you enjoyed it. I mean, it's really important to own and to remember all those small goals that we learned throughout, or that we accomplished throughout the semester. So let me know what type of question that was, and then give me an example like it. And it doesn't have to be something you made up. Take a look at your homework from that section, or take a look at our notes, take a look at your book as an example that's explained. You have all these resources. Find a question that looks like that question you really enjoyed and write it down, solve it for me. And 5, what was the most challenging concept that you mastered? Write a reflection, explain what you found most difficult and what made it click. And I want 3-sentence minimum, and then give me an example of the problem. So again, you can look through your book, your online book, you can look through your homework, you can look through our notes. Give me a problem that you know was really hard for you and you mastered and you learned from. So tell me, for example, why it was difficult, a challenge that it was for you. I don't know, just let me know. Let me know. I want to hear what you have to say, and also think it's so important to, most importantly, it's more for you to know that, hey, you learned so much in a semester, and sometimes we get so caught up on just getting by day by day, week by week, test by test. We forget that, hey, we learned 18 weeks worth of math, and that's so much. Think about when we started. We started with graphing a line, right? Doing your little X table, plugging it in, finding our intercepts. And now we're all the way here, you're working with matrices and 3 variables. You've learned so much. So I want to hear what you have to say. And the reason why I write that 2 and 3 sentence minimum is because I'll have students who just say, oh, it was really hard. I got it now. And that's it. So I want more than that. All right. And you'll have 3 questions that look like this. One of them is difference quotient. The reason why I emphasize difference quotient and that you don't forget that you learned it is because if you're going on to a higher math, if you're some STEM major, you're going to see difference quotient a different way when you reach calculus. And if you are going that high up, you're also going to take, after trigonometry, you'll take pre-calc, and you'll see this again. So I think it's important just to emphasize it again so you don't forget it. So I'll give you the formula. Your difference quotient comes from the formula of f of x plus h minus f of x over h. That's your formula, and I'll give you that. Now, our goal is to find what is the value of it once we're essentially working with the slope of a function that doesn't have a slope. And in the future, we interpret it differently once you work in higher level math. The most important part you need to focus on, if you do this much, it's half credit. Find f of x plus h. Now remember, whenever I have function notation that f and parentheses, it means that I have to go ahead and plug it in for x. So here are our x's, right? Here are x's. For each one of our x's, what are we going to plug in? For starters, we're going to plug in x plus h. That's that first part we're going to work on. Okay, let's go ahead and do that. So if I plug in x plus h, this gives me x plus h squared, because it has a square next to it, right? See the little square there? plus 2, and instead of x, we're going to write x plus h minus 3. Okay, we have to do a bit of algebra. Now here, this square, remember the square doesn't square each one. If you do that, there's a meme that says every time you do that, a puppy dies, because it's a common mistake we see in math. This means we have to multiply x plus h by itself twice, right? So then we have to multiply. You have to put x times x gives us x squared, x times h gives us xh, h times x gives us xh, and h times h gives us h squared. We combine like terms, our x and our h, and we get x squared plus 2xh plus h squared. And then in our next term, I'm left to distribute that 2. So I have plus 2x plus 2h minus 3. That's our first part. So if you've done this much, you got half credit. You did the f of x plus h. And I'm happy we did that much. Because that's the hard part. If you got this right, you're in good shape. All right, let's finish it off. So we found the part in blue. And let's write it again. So now we're going to show everything. Now we're going to show how we get f of x plus h. That's the part you found. Now we're going to write minus f of x all over h. Now, if it's helpful, always write brackets. So remember that you have to write things in brackets. All right, f of x plus h is what we have highlighted in blue right there. So we have x squared plus 2xh plus h squared plus 2x plus 2h minus 3. That's that first part in blue. I should have written that in blue. And then we have the rest of our equation, right? We have our function f of x. So minus f of x, what is f of x? F of x is x squared plus 2x minus 3. All of that will be divided by h. Okay, we have to distribute that negative, and that's going to cause things to cancel out, and it's going to work for our benefit. So now we have x squared plus 2xh plus h squared plus 2x plus 2h minus 3 minus x squared minus 2x plus 3. Now look very closely. What things cancel out or add to make 0? So I see minus 3 plus 3. Those add to make 0. I see minus 2x plus 2x. And lastly, I see an x squared and a minus x squared. So what are we left with? We're left with minus 2xh plus h squared.
It's a positive
plus
2xh.
2h. Thank you. Be very careful. All right, so all over h. Now the goal here is to factor in h. We see we have an h on each one of our terms. Let's go ahead and factor out an h so that we're left with 2x plus h plus 2 all over h. Our h's can now divide out, and our final answer is 2x plus h plus 2. And that's your difference quotient. You saw a problem like this, I believe, in exam 1 or 2. I want to say it's exam 1. I hope it's not exam 2 because I have your exam 2s, right? That was the last time I saw you when you took exam 2. Okay, now let's go ahead to our next question. Graphing a polynomial of a higher degree. You learned so much. Again, I emphasize this so much because we spent a whole chapter trying to develop a polynomial, solving for a polynomial of higher degree, synthetic division, listing your zeros. We spent a whole chapter to do this type of problem, graphing a polynomial of higher degree. So we see here that our polynomial, let's talk about a little bit about polynomial. We see our highest degree is 4, right? So we know it's even. And our leading coefficient is positive. So remember your end behavior, think of parabolas. Because it's even, we know our end arrows will be both pointing up, just like a parabola. All right, so we can answer some questions. That was question D. State the multiplicity of the polynomial and behavior. All right, let's go ahead and do A. Let me cut this out here. A, your question for A to A says list all possible zeros. So our possible zeros are made up of your factors of your last term over your leading coefficient. So we have factors of 12 over factors of 3. So you want to think, hey, what numbers can I multiply to get 12? I can get 1 times 12, 2 times 6, and 3 times 4. What numbers can I get to get 3? 1 and 3. All right. Now I want to list all our possible zeros. So all our possible zeros are answers for A. We're going to write all of our positive and negative options. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. And those are all the ones being divided by 1, right? And now I have to do all of my numbers when they can be divided by 3. So 1 divided by 3, 2 divided by 3, 3 divided by 3 is 1, 4 divided by 3, and 6 divided by 3 is 2. So now I have to add to it. So I have plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 4 over 3. And that's the ones that didn't reduce to a whole number. All right, any question about A? All right, B, find your zeros using synthetic division. So the way this works is our goal is to use synthetic division, and your goal is to get 0 at the end. Because we know when we get 0 at the end, that the number we're using synthetic division is 0. Now, I will give you a hint or hints so that you're not stuck doing synthetic division for an hour straight. Well, let's see, if it took you 4 minutes to do each one, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I would. No, it's 2, 4. There's 7 of them. You'll be there for a good half hour just doing synthetic division, right? So I'll give you hints so that you're not spending your whole time doing synthetic division. I'll tell you answers for this one, but we'll do them together. So your answers for this one are, or maybe I'll give you your answer as a hint, and I just want you to show me the synthetic division. It's -2, -1, 2 over 3, and 3. Let's go ahead and perform synthetic division. So -2, and for synthetic division, I have to use the coefficients of my polynomial. So we have to make sure our polynomial has every degree represented. So I go to the 4th power, 3rd power squared, 1 degree constant. We're good. So we take our coefficients. So that would be 3, -2, -21, -4, and 12. Let's go ahead and perform synthetic division. I'll do one of them because I'm running out of space. I'll give you more space, or you can take as much space as you like, right? You can always add another blank sheet to your scanned file. So we bring down our leading number, and then we're going to perform the algorithm. So we add and multiply, add and multiply. So -2 times 3 gives me -6. We add them, we get -8. -2 times -8 gives me +16. -21 plus 16 gives me -5. -2 times -5 gives me 10. -4 plus 10, we get 6. -2 times +6, we get -12. And we get that 0 at the end, just like we needed. So this tells us that we have a now reduced polynomial. So I always say the last one, that 6, will have an x, and then you have an x to a higher degree each time. So far, we have x plus 2. And then we have 3x cubed minus 8x squared minus 5x plus 6. Now you might be thinking, why do I have a -2 and a +2? Remember, you always write x minus your 0. And we just said that our 0 is -2. So if I want to write it as a factor, it'd be x minus -2. So it'd be x plus 2, which is what we have here. All right, so prove to me using synthetic division that they're all zeros. All right, let's go ahead and plot our zeros. I give you a hint of your zeros. Let's go ahead and plot them. So your zeros are found along your x-axis. These are where your zeros are found. They're points that cross your x-axis. They're your x-intercepts. So I have zeros at -2, right? Done. Have a 0 at -1. I have a 0 at 2/3, and I have a 0 at 3. All right, we know because of our multiplicity and behavior, I know our arrows should point up. And because the multiplicity of each zero has a multiplicity of 1, it's an odd multiplicity, so we cross each time. Remember, if we have a 0 that has an even multiplicity, it bounces that 0. So this would be a rough sketch of our polynomial. And you can even check your answers. You're like, check answers. Something you can always do is you can always go on a website. If you have more math, this website is really helpful. Wolfram Alpha. You can type in your equation and it actually gives you the answer. So we can type in, for our question, it was, I don't remember our question. So let's type in something random. So x, you can type in x squared, or you can type it into decimals. X squared. So that caret gives you the square. And let's choose that one right there. So it tells you your zeros, your factored form, right, your solutions. It tells you so much. And if you go on to calculus, this is something you can use too. It'll tell you derivatives and all that fun stuff. And you think you should take it as a class too. All right, let's continue with our review. Three, solve the system in 3 variables. So notice that I don't say you have to use matrices. So you don't have to use matrices if you don't want to. You can if you like it. If you don't have to if you don't. You can use elimination. You can use matrices. You can use whichever you like. I know matrices is easier to work with, so let's go ahead and do that one. And also serve as a review for elimination using solving using elimination. So our goal is to get 2 equations in two variables. So we have 1 equation, 2 equations, 3 equations. And I see that my second one, I already have it in 2 variables, right? All right, so we're gonna work with 2 equations and then treat it like a 2 variable question. So I'll write a winner's box. I never said it like that before, but we're gonna temporarily think of it as a different type of problem, right? So one of the equations we're gonna work with is x plus 3z is equal to -5. All right, now using 1 and 3, I want to create another equation that has the same variables, x and z. Why x and z? Because I have x and z in one of my winning equations. So I want to use these 2, and I want to get rid of the variable that's not x or z, which is left to be y, right? So I want to get rid of y. I have 2 and I have -3. I can multiply the first one by a 3, and I can multiply my second one by a 2, right? And that would give me a +6 and a -6. So when I add them, it'll give me that 0 that we're looking for. All right, let's go ahead and do that. So 3x times 3 gives me 9x. 2y times 3 gives me +6y. -z times 3 minus 3z is equal to 7 times 3, 21. All right, that last equation times 2. 2x times 2 gives me 4x. -3y times 2 minus 6y. And 4z times 2 gives me +8z. And that's equal to 0 times 2, 0. All right, let's see what we get. So our y's are gone. They add to make 0, and we're left with 9x plus 4x, we get 13x. 3z plus 8z, we get plus 5z. And 21 plus 0, we get 21. All right, so this is our other winning equation. 13x plus 5z is equal to 21. Okay, we're gonna ignore everything we have so far, and we're gonna solve just these 2 equations. I'm sorry, in case you're writing. We're gonna solve using those 2 equations for x and for z, just like we did in our review not so long ago. All right, I want to get a variable to add to make 0. I see this one's alone, and I have a 13 right below it. So if I multiply it by -13, that'll make it so my x's add to make 0. So let's go ahead and do that. X times -13 get -13x. 3 times -13, we get -39. Z is equal to 5 times 13, -5 times 13. You get 65. All right, last one. Well, let's add it to our one on the bottom. We have 13x plus 5z is equal to 21. All right, we made it so our x's had to make 0. And now we're left with 39 minus 5, negative 34z is equal to 4, 3, 44. Yeah. Okay. And we have 34z is equal to 44.
Wouldn't it be 86? Because it's a positive 65 and positive 21.
I knew something was wrong. I was like, I think I set up some of the right whole numbers. Thank you, Abraham. All right. Your teacher can add. All right, so we get 86. All righty, so we divide by negative 34. And we get that z is equal to, I'm guessing 2. 86 divided by 34. Oh, it doesn't divide evenly?
Stop.
No answer. Doesn't divide evenly. Oh man. Okay. So 86 divided by 34. We have to reduce. So 86 divided by 34. It reduces to 43 over 17.
Negative.
Negative. Okay. Now we found z. Let's take a look at x. So let's plug it into our equation. So we have x plus 3z is equal to negative 5. And now we know that z is equal to negative 43 over 17. All right, so let's plug that in for z. So I have x plus 3 times negative 43 over 3 over 17 equals negative 5. So we get x minus 43 times 3, 129. 129 over 17 equal negative 5. We add it. And get that x is equal to 5 plus 129 divided by 17. And we get 214 over 17. So we found our z, we found our x. Lastly, let's find our y. So we go ahead and choose one of our initial equations. And we go ahead and pick whichever one we want to find our last variable, which would be y. So let's go ahead and pick that first one. So that first equation is 3x plus 2y minus z is equal to 7. And now I know that x is 214 over 7 plus 2y minus z. Z is negative 43 over 17 is equal to 7. All right, so question?
Oh, when you were finding x, you have it as negative 5 plus 129 over 17. That would make it, that wouldn't make it to go into the 200s, would it? 214, you would subtract.
You're right. That's not right.
You forgot
That
the
would-
3.
The 3 where?
In front of 214/7.
Over 7. I did forget the 3. But that one, we gotta fix that one, right? So it's not 214/7. It's, once we reduce it, it's 44/17. Because it was a -5. So then we would have to, I didn't show the work, but what's going on here is we get a common denominator. So 5 times 17 equals, so I have -85 over 17 plus 129 over 17. And that gives us 44/17, which is how we got here. And my mistake was that I didn't consider that negative. All right. Let's go ahead and continue. So 3 times 44, and get 132. So we're at 132/17 plus 2y plus 43/17 is equal to 7. Well, let's see how it comes denominator, right? 132 times 43, I'm sorry, plus 43. We're left with 175/17 plus 2y is equal to 7. And subtract 175/17. So I have 2y is equal to 7 minus 175/17, which gives us -56/17. Divide by 2 to get y by itself. So I'm left with y is equal to -28/17. I promise I'll give you whole numbers for your exam. I won't make you work with fractions. I wouldn't make it more stressful than an exam already is. All right, so once we're done with today's review. Once I'm gone, I'm going to type up your review. Not your review. I'm going to make questions that are similar to your review, and those are your final. And I'll make it open as of today. I think it'll take me about an hour to get it up, so you can go ahead and take your tests. I'll see the latest I can make it available. I would like to make it available until Thursday. The last time I made something available on Thursday, or try to make it available on the Thursday of next week, it kind of didn't let me. So I wonder if I can change it. But if so, I would like to make the due date to be the 21st. So 5/21, be your due date for your final. All right. So are there any other questions before we're done with our last meeting?
No, thank you.
No? All right. You have your review for your multiple choice. You have your review for your open response. If you'd like, after you're done with your SI session, what I would do is I would start looking at my homework and my tests, my book, and I would answer those last 2 questions. What was the concept you enjoyed the most, and what's the most challenging concept? I would answer those 5 and 4 just in the paper, just so I have those out of the way. And so I'm left with just the multiple choice and those 3 open response questions. Alrighty, well, I guess that's it for today. Thank you for a great semester, even though it was a totally hectic semester. I never had anything like this happen. None of us have ever had anything like this happen. So I wish you the best in all of your classes and all your math endeavors. If this is your last class, then I'm happy for you. You made it through. Hopefully you get the grade you want. Thank you so much.
Thank
Thank you,
you.
Professor.
Thank you.
Thank you,
Thank
Professor.
you.
Thank you, Professor.
Thank
Thank you.
I try to make it as accessible as we could in this short notice. All right. Happy studying. If you have any questions, I am still available via email. I will post some office hours, so in case you have some last minute questions, I will, aside from making office hours, I will make it to the test. I'm thinking 3 tries is more than enough, and they're not timed. So you could take it one time around, kind of see what things are going, how they're looking at, and try to get a sense of what you're doing. Do your review plenty of times, first of all. Do your review, make sure you understand those questions, try it, make sure you do really good. So I'll give you 3 tries on the open response. On the final review, I'll give you 2 tries, just in case you want to do 1 try just for you to see what's going on, and then upload it a second time. All right, so for your open response, it's just like your homework. I see a lot of wonderful group chat messages. Thank you so much. You guys are a really good group, and I'm really sad we weren't able to finish together in class. But it's to be safe, right? So it's okay. All right, well, have a nice finals week. I hope you do well in your other classes as well. And if you see me around, say hi. And if I don't say hi, it's not because I don't like you, it's because I'm not wearing my contacts or glasses and I just can't see. All right.
Ms.
Bye.
Bakari,
Yeah.
I have a question. Over here on
Yeah.
2y equals negative 56 over 17, you divide the 2 to both sides. You only divide the 2 to the negative 56?
Oh, so if you want to, you can go ahead and expand it. So remember, this is division, right? That's division. So you can think of it as negative 56 over 17 divided by 2. And how do we divide fractions? We have negative 56 over 17. We multiply and use the reciprocal of the second. So 1 over 2, right?
Yes.
And then it can cross cancel. 56 and 2, that divides by 2. So we're left with negative 28 over 17.
Okay. Thank
Yeah,
you.
no problem. You would have been thinking about that all night. You're like, how did she get that? What's going on? Is she creating math? She never told us this.
Okay.
Alrighty, well, have a nice semester. Study hard for your finals. Alrighty, bye.
Thank you.